where you have to do this. So I'm just going to show you. And this is a basic case of Pythagoras theorem, or right angle theorem. A squared plus b squared equals c squared, which is 7 squared plus 19 squared equals r squared, because r is our radius. And 7 squared is just 49. Oh, I always messed this up. Is it 341, 381? No, it can't be 381 because it has to be at least 40 away. 361 most likely. That makes sense to me. Let me just use my calculator. Yep, 361. And obviously when you add these together, that's going to be 410. I think. Yeah, sounds about right. And then we just got to take the square root of that. And that's going to be 20 point something. That is 20. Actually, sorry, no, we keep it in exact form. So just going to be square root of 410. So radius is just square root of 410. Yeah, have a habit of keeping it in exact values until the final answer. If the final answer allows you to, give you a decimal answer, then that's fine. But here it doesn't say exact value, so you probably could just write the decimal value. But I just want to get in the habit of writing exact value, just in case when you need to. All right, so radius is square root of 410. Now I have all three sides. Find the angle, principal angle. So how do I find the principal angle? Well, before I find the principal angle, I need to find the angle inside this triangle. And the easiest way to find the angle inside is to use my primary trig ratios, SOHCAHTOA. Remember, this is opposite because it's the opposite side of the angle. And this is adjacent. So the easiest one for me would be to use tan theta, or I guess technically it's not theta, it's beta because it's the angle inside. So tan beta is equal to opposite 19 over adjacent, x 7. 19 over 7. So what is beta? Beta is just the inverse tan of 19 over 7, which if you do that right now, 19 over 7, shift 10, you get an answer of 69.8 degrees, rounding up to the nearest tenth. Oh, thank you, boo. Wah, 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 wah. Okay. So beta is 69.8 degrees. So we know the angle inside here is 69.8. Oh, that was very poorly done. All right, so we know that that's the angle inside. So what's the right angle? What's the principal angle? Well, the principal angle, theta, is equal to, we know that this right angle is more than 90, but less than 180. So am I going to do 90 plus 69.8? The answer is absolutely not. That's absolutely never the case. You never use 90 or 270 in your calculations. You only use 180 or 360. So we're going to do 180 minus 69.8. And that is how you get the answer for the principal angle. So 180 minus 69.8. I get 110.2 degrees. And that's the answer. Oh, so they didn't round to the nearest decimal. They rounded to the nearest whole number, so that's fine. I guess the question didn't really state how much to round, so they just did 70 degrees and 110 degrees. That's fine. Pretty straightforward. All right, here we have example 3. So same thing, we have a point 5 and 11, so x and y. 5 is probably going to be here somewhere. It's going to be here somewhere, so the point is here, and you draw your terminal arm. Okay. Draw a sketch, determine the exact value of r. So here they say exact value, see? And determine the primary trig ratios. Yeah, so this is the one, and it says nearest tenth of a degree. So this is a lot more detailed. So let's do this. First things first, always draw your triangle correctly. Second, label your angle, the side lengths of your angle. We know that the base of the angle is 5, and we know the height of the triangle is 11 because the y value and the x value. What's r? Well, we do the same thing. 5 squared plus 11 squared equals r squared. That's 25. That's 121. That's r squared. That's 146 r squared. R is equal to square root of 146. So that's what you write because it said exact value. So you cannot write a decimal in this example at all. So square root of 146. Remember, this is our angle here, beta, or technically it's also theta in this case because it's quadrant 1. But now they're asking for the primary trig ratios for angle theta. So since this technically in this example here, this is also theta because it's quadrant 1, we could just write sine of theta is equal to opposite, which is 11, over hypotenuse, which is square root 146. We can write cos of theta is equal to adjacent, which is 5, over hypotenuse, which is square root 146. Or we can write tan theta, which is opposite, which is 11, over adjacent, which is 5. So these are my primary trig ratios. Now it says to calculate theta. So to calculate theta, I'm just going to use any equation I want. I'm just going to use this one. Why? Because it's whole numbers. It's easy to deal with whole numbers and square roots. So just do the inverse tan of 11 over 5, and then round to the nearest decimal. 11 divided by 5, shift 10, and I get an answer of 65.6 degrees. That's the answer. So make sure you write your 3 trig ratios. Make sure you use one of those equations to actually solve for the angle. And here we have the 3, 11 over root 146, 5 over root 146, 11 over 5, and then 65.6. Very easy stuff. And final example. Here we have an equation, but remember, this is also an equation. So don't be freaked out just because your equation is a little bit more difficult. All you have to do is just solve it. So move the 1 over. 3 cos theta is equal to -1. Divide both sides by 3. Cos theta is equal to -1 over 3. And there we have it. That's how easy it was to now have the exact same type of equation. Just took 2 basic algebraic steps. And now we can solve for theta. Theta is just equal to inverse cos of -1 over 3. And what is the inverse cos of -1 over 3? Well, let's do that. If you do it correctly, it is 109.5 degrees. Actually, do they say? They don't really say around to the nearest 1 decimal place. I just usually my rule is try to always just keep 1 decimal place to try to be that accurate. All right, so this is the answer. We're technically done because we resolved what angle will give us a value of -1 over 3. But let's draw this out. To solve the following equation for angle theta between 0 and 360. So when it's written like that, we need to solve for all answers possible. We know the first terminal arm is going to be in quadrant 2 because it's bigger than 90 but less than 180. And we know that this is a